Hello, everyone, ladies and gentlemen. Our next speaker is someone who has spent the better part of 2 decades where testing generally matters. Inside one of Europe's largest banks for over 20 years at ING, he has watched teams invest heavily in performance testing, only to end up with dashboards and matrices and reports that still leave one question unanswered. Will this change be safe in production? That question and the gap between testing and true reliability engineering is exactly what we will be unpacking today. His session, from load testing to reliability engineering, making performance testing production behavior, goes beyond tools and dashboards. He'll walk us through the engineering practices that actually make performance signals meaningful: SLOs, risk based test selection, realistic workload modeling, observability, and production feedback loops, and how these can be woven through development, CI/CD, and operations to build real confidence in what ships. If you ever looked at a green test report and still felt uncertain about hitting deploy, this session is for you. Please join me in welcoming to the TestMu Conference 2026 stage, Stephan from ING Netherlands. Stephan, the stage is all yours. We are excited to hear you.
Thank you. Am I there? Yeah, I see myself.
You are, yes.
All right. Thank you very much. Hello, everybody. Everyone. Yeah, today I just have one simple question I want to explore, but it's a bit deceptively. Will this change be safe in production? Teams do a lot of stuff. They run load tests. They collect enormous amounts of data, and they produce detailed reports of a lot of pages, but they still feel a bit uncertain. Can they really go live? Will everything will be fine? I have one argument. This presentation is that performance testing only becomes predictive when it stops to being an isolated test activity and becomes part of continuous reliability engineering practice. So yeah, let's start with why running more load tests doesn't automatically give you a better answer on the question, is this safe in production? Performance testing, it's not primarily a testing problem, it's an engineering feedback problem. I think the load test will trigger a lot of feedback, but you have to unpack this present yourself, right? You can simulate users, you can execute scripts, you can generate metrics, but you cannot by itself have a load test tell you whether the workload is realistic, whether you in fact did the right tests, and also if the test results is good enough for production. There's a lot more to it than just a generic test report with some latency numbers. So the valuable output is not the report, it's actually the feedback that you get. And you will be able to have a trustworthy engineering decision if you treat it such. So the tool can generate load, but the system should tell you if the change is safe. I think that's very important to remember. But why am I doing this talk, right? Before I build that argument, I think I should briefly introduce myself, but also why does this matter for me personally? I'm Stephan. I'm from Amsterdam, so sorry for my Dutch accent. I cannot help it. Maybe maybe if I go to the English class a bit more. But so I'm a product manager for ING's global performance and resilience engineering platform. But my work lives at the intersection of performance testing, but also observability, resilience, and production reality. So a large part of my role is helping teams figuring out how to turn the technical signals that are created into decisions that they can actually trust. I've worked at ING for over 20 years now, and I got one purpose, and it's giving confidence to teams to go to production, but also making reliability part of everything they do. Because reliability is very crucial for, I guess, every company, but for a bank specifically. Next to this, Maybe you all recognize this T-shirt. This T-shirt from DevOps Days Amsterdam. I'm an organizer there. I also organize SRE&L community events. Last year, I like to joke around that I'm a director of social technical mayhem because of the intersection between people and technical stuff. But I guess there's no controlling, no such thing as controlling mayhem. So it's more like a joke. I'm not a regular conference speaker. I'm normally behind the stage, but from time to time, I enjoy it. So one fact, I do really like craft beer, and this picture is taken at my favorite craft beer brewery. But there's only one thing which is a bit weird for this picture. The beer is actually alcohol-free, which is something I would never do unless I'm working, and at that time I was organizing. So yeah, that's me. I do am curious of where you all from. So post it in the chat. That's yeah. I think that being said, the scale at which we work is one reason this cannot remain an expert-only activity. So that's the next slide, which is our corporate slide. Since I work for ING, ING is a large international bank, and I will not name all these numbers. Okay, maybe I do one. It's 350,000 deployments a week, probably a bit more now because this is slide from last year. The importance of this slide is scale. We operate on a large scale in a distributed environment with thousands of services and a very high delivery cadence. So everything we do is quick and large. At this scale, performance engineering just cannot depend on a small number of specialists interpreting every graph manually. We do, for example, distributed testing of over 100 microservices at a time. And if you need to spend your day on figuring out the results of it, I think your day is already done. And then the next day, you will have to do it again. So it's like bringing water to the sea, I think they say. It's a bit hard. So this brings us to the difference between simply executing a load test and engineering for reliability. I think that's what we are looking into now, right? A load test, it produces data, but the reliability engineering actually produces decisions, and this is really true. So above the water of the iceberg, you see the test scripts, you see the load generator, you probably see a dashboard and response times. But below the water are all the elements that determine whether we can trust the results. Your objectives, your workload modeling, your observability, your dependencies, your capacity management, your analysis, your feedback, production feedback, all those kind of things. And if any of those foundations are weak, you will have probably you have a Titanic, because then it will not go to production without the incidents. So instead of thinking about performance testing as script, maybe a load test, we need to see it as a system. Okay, so performance testing is a system. It's not a script, it's not a test, it's way more complex. Reliability performance emerges when customer journeys, measurable objectives, realistic loads, and observability and resilience are evaluated together. So how do you bring this all together? I will show that in a graph later. The hard part is not pressing the button, but to start things, or the pipeline in our case. The hard part is actually deciding what to test, risk-based, why it matters. Is the environment right? The test data you use, are they credible? And what actions should you trigger in your performance test? That's the judgment that the engineer needs to make. Let's unpack the connected considerations that support that judgment. So there is a lot to it. The system is way broader. In order to do it right, we need realistic workloads, but we also need measurable objectives. You need an objective to determine if you meet the objective, right? You need to have good test design. Your capacity needs to be in order. Your observability needs to be on point. It's very crucial that you also use observability that helps determine whether things are right in production. You need to have proper test data. You need to be aware of your dependencies, and which is not that easy if you work with 1,300 microservices. Being aware of your dependencies that really matter, that's a big task. You need to be resilient. You need to automate things because, you need to repeat it. It's a loop, right? And you need to spend a lot of time automating analysis on it. And these are not one-time activities. It's not like before in the past you have one project, you spend like a week doing some performance testing, you go to production, and then the next few months you'll be just waiting for the new release. No, it's continuously. It's sometimes it's multiple times a day even. There are teams that go live like multiple times a day. Some go live every sprint. Some go live a few times a sprint. So there's really there's a lot to it. I'm not going to explore every box today. I think that will take too much time. But I will focus on the elements that make a test results really predictive as much as possible. So those are objectives, risk selection. I will tell something about workloads, how to create those. Analysis I'll spend on time on. And also, for me, one of the more important things is also the production feedback. So crucially, this loop should not appear only at the end of delivery, and it's actually also not a quality gate. It's continuous feedback. We want to avoid having our ship stuck in the Suez Canal. Was that last year, right? That it was totally stuck there. You don't want that. Everything that's related to performance is a part of your design of the most useful decisions you already have made, and you can see bottlenecks, but that doesn't mean that you can easily fix them. It could be architecture, it could be dependencies, assumptions, and so on. So performance signals should inform design, development, CI/CD, and release decisions, and also production learning. So it's not a gate at the end. So also the goal is not a final performance certificate that you can say, okay, done it, but it's actually a continuous stream of evidence and feedback, and it will continue. But speaking about evidence, right, it can guide you, but we also need to define what good actually means. Because you cannot test what you have not defined. I guess that's something that most testers can relate to. And for functional testing, I think sometimes, everything is like more or less specified, but for performance testing, a lot of things are not. And teams just begin with creating a script and put some load on the system, see what comes out of it. But I actually prefer to begin with the intended outcome and work from there. So which user journey matters? What are your requirements? Which service level objectives do you need to meet? What degradation is tolerable? If you do a high load test, what is your tolerance? Over what period? And also more metrics, they do not create clarity, but objective does. So to define those objectives, we first need a shared language for service behavior. And that's where SRE comes into place. It's very related to performance testing, actually. And I would say it's part of it. So the signals tells us what's happening, but the objectives tells us what is acceptable. Within SRE, there are 4 golden signals, and they give you a balanced view of system behavior. They are actually a set of metrics used to determine whether a service is healthy. They're called golden because they provide a simple and effective way to detect most production issues within drowning into the hundreds of metrics that your application will log, right? It's very high level. In this chapter, we will explain them, and also we will tie them to another SRE concept, which are service level objectives and indicators and error budgets. And the indicators, they help you to define important, and the objectives help you define, okay, what is good enough service quality means. And your error budget is actually anything within the margin of your objective. So it is turning your behavior into precise service measurements. And those are also the metrics that are very interesting for you in the analysis. So yeah, visibility is valuable, of course, but visibility alone does not produce a release decision. So you need to have a little bit more. And it's very important to know, when you need to hit the evac button, when you're not meeting your requirements, then you don't want to fly your plane, but you actually want to fix it before flying again. So, but let's begin with the 4 signals that gives us the quickest balanced view. Anybody recognizes those 4 golden signals? They're latency, traffic, errors, and saturation. Latency is response time. How long does a service take? We all know that is it time is money, I guess that's the saying. But also we probably know that the slower your website is, the less money you make. There have been experiments there on big web shops adding like 20% extra latency actually costs revenue. There's a good saying that you are quick enough when your customers think you're quick enough. Reliability is also in the eyes of the beholder, I guess. Traffic is how much demand is on your system, right? So that's more people going on your system. And then, of course, you have errors. It's fair to say that you don't want too many of those, because every time you throw an error to a consumer, not every error has to be thrown to the consumer. Of course, you can also do like repeat requests, for example. But if you throw too much errors, you're not reliable anymore. And saturation is a different one. It tells you actually how close are you to a constrained resource to its limits. So if your system is CPU bound, you probably need to watch it when the CPU goes like 85%, then you might encounter some queuing. One signal doesn't mean that much, I think. I mean, of course, it means a lot if latency is 4 times as long, but it also, the trick is combining them all together. So if there's more traffic, you might have a bit more latency. You might have a few errors as well, and your saturation will become more. So talking about saturation, it's especially valuable because it can really expose what are the needed resources to create the right service to your customers. So let's go to the saturation. Like I said, right, it measures how much of a critical resource is being used relative to its useful capacity. And useful capacity, that is a little bit difficult to determine, right? Can you actually hit the 100% CPU mark, or maybe not? Maybe you don't have enough threads to do that. So there's a balance between all the resources you need. You need enough memory. You need enough queues actually to use the CPU wisely. So it's also very interesting when you do performance testing to understand the balance between those and tune them. It's no use to put 100 CPU and just 1 MB of memory and 1 thread. You need to balance it, so you will be able to actually move towards the ends of your limits of each resource. For performance testing, your goal is to identify and manage the resource that limits your journey. So basically, your next bottleneck. I think most performance testers all went bottleneck hunting and trying to figure out why they cannot put more load on the system. So signals, they explore behavior, but the next step is actually translating that behavior into something that is meaningful. So that's objective. So you can actually decide. So for those, we have the reliability chain. And on the left, you see the golden signals. In the middle, you see your service level indicators. And to the right, you see your service level objectives. I think it's fair to say that not all golden signals are actually good service level objectives or indicators. Like they do need to have a direct relation towards your user experience. And your user experience is not determined. Your user doesn't experience, for example, 100% CPU. They experience high latency. So high latency is a better indicator than saturation. Maybe saturation causes you high latency, and maybe you want to alert on it, but don't use it as an indicator. The same goes with traffic. It's not the best indicator, I think. So that being said, the golden signals, they reveal what the system experience, but the signals that are important are your SLIs. So those are the metrics that you use to validate the performance. They're user-focused measurements such as latency or the percentage of successful requests. And then SLO, those service level objectives, they set the target for the reliability, what you need to meet. They actually define what is acceptable and provide a threshold, and those thresholds also are very interesting for your decisions, your guardrail. So also for your analysis, those are the ones that you need. So simply said, SLIs are what you measure, SLO is what we aim for. And your golden signals are contributing towards that. So that being said about the reliability chain, but now we know what acceptable means, but we can, how are we going to measure it? What kind of test or experiment exposes that? And that's the next part in this presentation. I think this is spot on. Do not choose a test by habit, choose it by risk. Maybe some of you have been in test management risk meetings, figuring out, okay, what is the change and what are the risks that accompany it. I think it doesn't happen that much because we have a very high cadence, but it still makes sense. If you run it, you build your software, you run your software, you know exactly what changed, and you also know what the risk comes by. If you created a new endpoint, that's a different load test than that you just fixed some logging. So it doesn't make sense to run every available test. I think it also gives you a lot of false confidence. You really need to be aware on which tests deliver which value. So that means a risk. So what failures do you need to understand? Is it demand? Is it a sudden surge of users? Do you need to know your capacity limits? Maybe if your cloud is scaling properly. Are you worried about long-term degradation? Do you do a lot with data, or do you need to recover from something? Those are, then you need to select the test that best fits your answer. So All those tests are not maturity levels, they just answer different risk questions. So here are the major performance tests that you can do and the specific question they answer. Okay, so I put in 6. I think there are a few more, but for me, those are the ones that actually makes the most sense, the most used. Let's start with the load test. I think it's the most general thing. It feels more like, okay, let's just test it and see if there's no performance degradation. You don't need to run it that long, but it gives you a bit of a feeling if you can run under normal load. So does your service meet the latency requirements under normal, but also you can do peak load. You can do like a stress test, which actually the point is having your system fail. So you just want to keep on ramping up until something actually breaks, and that's probably one of your system resources, of which you are the saturation golden signal. Could be like your memory is finished or your CPU is finished. Could be anything. Then the spike, I think, at least from ING perspective, and I guess a lot of e-commerce companies as well, there's no such thing as people just gradually using your system, and it's just there's no peaks. It's always the same. They stand in a line and they're very patient. No, there are moments that your system needs to perform at its peak. Those can be short moments. You want to test those. You want to see if it can meet the short peak, but also if it can recover from it. Volume testing, that's more about data, putting data on the system to see what happens. Endurance testing, that's about showing that your system can actually handle a long-term load. I think it's a bit overrated, to be honest. If you have proper observability, you don't need to load test for days and days. I mean, if you want to figure out if there's any memory leaks or something, you will probably see it earlier before it breaks. So that's about the testing, but I can also give you maybe a few practical examples. Let's say you have a ticket system, and in the Netherlands at least, we are normally releasing tickets on Friday morning. So if there's like a big international star, I don't know, I'm not really into this kind of music, but who knows, Beyonce or whatever, and she goes to the Amsterdam Arena, there's a good chance that at 10 o'clock on Friday morning, they release the tickets, and then people are in a digital line and your system will get flooded. So you might want to see what happens in a spike, but you also probably want to test the boundaries of your system. So that means that you're interested in probably 2 tests, your spike and your stress test. You're not that interested in endurance. You're not that interested in your regular load test, because you'll probably see it before you see the spike. You will also see your latency. So that is an example of where some other test doesn't make any sense. But if you have regulators, we have a lot of regulators in finance. Maybe a regulator tells you, well, it's nice, but you have to prove that your system is capable of handling load for a longer moment before you go to production. I do have a question for you. I don't have a prize, but we have, I know one test, one endurance test, which is the longest at ING, and I want to ask you how many hours you think it is. Type your answer in the chat, and I will reveal the answer later. When you run cloud, for example, you want to see if your system is able to upscale and downscale and how that works. If you see, are the resources added? Does it mean that your latency is fine again, or does it take ages for it to recover? Those kind of things you will do in a scalability test. But yeah, I think one demand is only one part of your risk, right? You can also have outside events that cause issues. For that, you have resilience testing. So it's not only about being fast, but it's also about understanding how your system behaves when it runs suboptimal. For that, you can do chaos testing, but you can also have more controlled tests like failover testing, or just increase latency on the system, or do a resource exhaustion on your CPU. Maybe run a process on it, claim it all, and see what it does with the latency. And for us as a bank, one of the tests we do regularly is disaster recovery. We run on multiple data centers, as we should be, but we should also be able to run on one in case there's an airplane landing on our data center, which could be, because I know we have a data center not that far from Rotterdam Airport. So it never happened, by the way, but it could happen. We do that test regularly to prove that we can manage running over one data center with all the dependencies. And not that long ago, we actually had a nice finding on my platform. My platform is running on VMs, and I had 4 of those, 2 in each data center. But there were, I have 2 flavors. One is for high load test, and one is for regular test. And guess it was not divided properly. So if one data center was gone, I had 2 VMs only capable of running regular test, and there were no VMs over for the high load test. So I actually had to increase my my resources. I had to double those just to be able to deliver the service that we required. And sometimes that's not really clear on paper. You just need to see it. Of course, you can think about it, but there was no, we didn't. So if you have picked the right experiment, which you do need, the results can even still be misleading if your workload is not realistic. If everything you mimic in a performance test, needs to make sense. So if it doesn't, then the outcome will be very unrealistic. And for that, you need to model reality and not assumptions. And I do realize that there's also a load test done on new systems that are not in production yet, but I think that most load tests are done on things that are running in production. And if you are not running on production, then you, of course, need to make assumptions. But as soon as you go live, then you need to look at those assumptions. So if you have a technical perfect script, but your wrong user distribution, your timing, your data, they all lack, then you have very little tell about production. So the predictability is very low. So workload modeling is where we turn production behavior into testable hypothesis. If the workload is wrong, your prediction is wrong. So how do we build a workload model that is representative and repeatable and credible? I do have a method for that. It's actually 6 steps. So you start, when you're running on production, you start looking on production. What happens? What traffic do you see? What timing? What are the latency and the errors that you see? Which endpoints are hit? Then, of course, you want to see also what users do. How is the flow? What was actually the user behavior? For that, those 2 you can put in a transaction mix. So how do they mix together? And you create profiles for that, so load profiles. You execute test, and then the last step is, I think, is the most important. Validate. So what are your assumptions, and are you close to the reality? So that's basically how this works. You make it repeatable, and you make it data driven. So you validate the model and you compare it and you investigate deviations, and then you decide to fix things. But it's still a hypothesis about production. It tells you how close you get. I would personally include here, you could create like a score on how close you are. You can score all those profiles, but at the end, yeah, there's always deviations. You need to simplify things. You cannot just create 1,000 different profiles. So there will be simplification. So if we have the right objectives, the right experiments, the right tests, and your workload is fine, you still need to determine how your results, what do they mean? Are they good enough to go to production? And data, the metrics, they don't create the confidence, right? It's the evidence you create that do so. Even your dashboard can be green, but maybe a bottleneck is hiding, or you miss something. So you need to correlate test behavior with application behavior. So your test tool will tell you from a user perspective what's happening, but your application, your infrastructure, logs and traces will tell you what's actually happening on your system. You need to correlate those, and you need to spend, you need to make sure that you do the right conclusions. So for that, we need baselines, we need objectives, and we need to confirm that important journeys and components were actually done. So the test result, it's not a conclusion, it's just the beginning of the investigation. So it's where the fun starts, I guess. So, and this is also where automation can remove a great deal of repetitive work without replacing engineering judgment. I think that's not the goal from automation, right? You just need to make sure that there's proper feedback for engineering judgment. The engineer doesn't want to do repetitive work, right? It's seen as toil. They just want to make sure that they can benefit from performance analysis automation, for example. So yeah, it's the beginning of the investigation, and it's I think it's, for most people, it's probably the most fun part. So this is how you can set up performance analysis automation. I think when you look at a performance test, you ask yourself a few things, right? You ask yourself, hey, is it better or worse as it used to be on a high level? I mean, that's an important answer. And if it's worse, then it's a red signal, right? You need to figure it out. But even if there's not really a lot of deviation, then you can still introduce slow things that will bite you later, because your load test is probably like maybe a few hours. And in a few hours, if you have a gradual increasing latency and it's not too bad, then you might not see it. But production is 24/7, then you will definitely see it. Maybe in the weekend, if you deploy on Friday, maybe on Sunday, there will be issues. I had it in the past, by the way. So yeah, then it sucks, and then you're thinking, what's happened? I tested, and yeah, then you need to look into it better. So the first step, I think, it's collect it with your metrics from your infra, from your application. Then the high level benchmark. How does it look compared to previous tests? I think it's that's really a big question which you can automate quite easily. It's not only comparing it to previous tests, but also you can compare it to your high level targets. Maybe it's still acceptable, but you miss your target, and you do need to look at it. Then the patterns, that's where where normally the performance engineers look at a lot of graphs. These can be like peaks, they can be slopes, they can be missing loads, it could be whatever. And then you want to validate the coverage. And that means actually comparing it with what's happening on production. Do you hit all your endpoints? Do you hit all your components? And for those endpoints that you hit, are those the right numbers? And maybe you also want to look at the performance metrics. Is it the same as in production, or is it slower? Maybe because you use faulty test data, or your test environment is not scaled properly. So there could be anything. You want to detect anomalies together with the patterns, and yeah, you want to do an improvement round. So you want to improve things to get it better in the future. You need to prioritize them and make it count. So yeah, but even this still gives us a prediction, and only production can tell you at the end if the prediction was credible. Okay, so a test is only predictive when it was proven right. And this tells us exactly what we expect to happen, right? So, but the production, that's what matters. So you need to compare workload, coverage, latencies, errors, saturation patterns, and user outcomes. And when prediction and observation differ, then it's not simply a failed test, it's feedback. And that feedback should not disappear in another report. It should improve your next decision. And this is where we come, at the almost final part already. I'm not sure if I'm still on time. I think so, right? When a test ends, your feedback loop continues. It's not the end of your journey. Teams do tests daily, right? So it's just another end, and you need to make sure that you learn from it. So the production behavior informs your objectives. Your objectives, they shape your experiments, and experiments produce evidence. So your analysis, you turns your evidence into learning, and learning improves the next workload model, and so on. And that's the loop that you need to look for. And this is where performance testing actually becomes reliability engineering. If the loop is there and the learning feedback is there, then you can improve the results from test to test, and you can make sure that production is actually getting better. So before we end, let me turn that loop into 5 practical things you can start applying. The first one is really, for me, I think the most important, right? Make production your friend. Don't treat performance testing as a loose thing. Make sure that what you see on production, that you use it for your test setup. That is, for me, the most important lesson here. And for that to work, you also need to make sure that your service level objectives and your service level indicators are driving your decision. So when you do your performance analysis, you should know which metrics are actually crucial for your customers, and steer on that. Don't test by habit, but test by risk. Be very critical on which test you're doing and why. If you cannot explain why you do a test, my suggestion is not to do it, except you do the smoke test. I mean, if you do a smoke test every morning or every build, that's perfectly logical. You just want to have quick feedback, but that you can explain. Make sure you learn from every run, and treat reliability as trust. Trust is very important in any business. They expect something from you. Your users expecting something, and if you don't deliver that, then you lose trust. So those are some practical actions you can do. Let me close off with some final thoughts. I started this presentation with the question: will this change be safe in production? I do think that you can never answer that question with 100% certainty. But if you define meaningful objectives, you choose your test intentionally, you model the production reality as much as you can, you analyze the evidence, and you learn from each round, I think you can come very close towards that state. I do think there's more to it. For me, reliability is not a final test. It's a way decisions are made. So if you look at it, make sure that your system and the way you deploy is not critical. Don't deploy everything at once just before your stock exchange market opens and hope for the best. Just make sure that you are deploying on the right moment. Use canary releases, candidate releases. Make sure that the feedback is there before you move on. And that being said, I think I just want to end with one quote. I got inspired by that. I don't know if you know Charity Majors. She's a thought leader. She's the founder and CTO of Honeycomb, which is a very nice observability software as a service. She said, test in prod or live a lie. She doesn't mean that you need to test in production, but she just means that everybody's testing in production because production is where it actually happens. You did all your tests on a pre-production environment, but the real test is on production. You will see things that you didn't expect because of user behavior you didn't foresee, or maybe of dependencies that you didn't trigger in your tests. Maybe it could be anything. So that is what she means. She doesn't mean that you should start creating a load test script and write money from one production account to another. I would not advise that. Although, fun fact, I did personally test on production before. I think it was like 15 years ago. It was on the open environment, so there was nothing, no personal data whatsoever. And that was just because we didn't have a pre-production environment. It was hosted by an external company, and we came there at 11 in the evening, and like at 1 o'clock, nobody was using it, so we could we could have a go at it and see what came out of it. But it's not a practice I would encourage. I would encourage to use production as a test environment by real users and check what's happening there, and make sure that your system is bulletproof. So bulletproof meaning resilient as possible.
Perfect.
And for that, I'd like to thank you in your interest, and I think we can go to some questions.
Yes, we would have loved to take questions, but it seems like we're running over time. So we'll
I'm running
just
over time. Oh, sorry
a
about that.
little bit, a little bit. Yeah, but what
Oh,
we're gonna do is we can note down the questions. Folks, we have pinned Stephan's profile on LinkedIn as well. Feel free to reach him out. It's there
yeah.
on your screen
You
as well
can
as you
scan the
see.
code. It's Stephan
Yes,
Mousset. There are
yes,
not that many with my name. Hit
yes.
me
So
up.
unique.
I would
Yes.
love to get in contact with you, and I love to hear how you make performance testing, predicting the production behavior.
Perfect. Great. Thank you so much, Stephan. Thank you for coming up. Interesting talk, interesting topic. And from entire TestMu AI team, we would love to thank you. for participating and sharing your thoughts here. And thank you everyone who attended. Feel free to reach out to Stephan. He's available for all the queries you have. Thank you.
Thanks for having me. All right. Bye bye.
Bye.